Hey, in this video we'll be talking about typecasting in C++. So typecasting is a way of controlling the type system of C++, of the compiler, and enforcing type conversions where possible. So the simplest kind of typecast is an old one from the C language. So let's say I have an integer and I want to convert it into a float. I can make that explicit by putting the type I want to convert to in parentheses and then putting the value afterward. So this is going to convert an integer into a float. Now, a lot of types are compatible by default, so C++ knows that integers can be converted into floats. It accepts an implicit conversion here, but if you want to be explicit, then you can use a typecast. There's another kind of typecast, does the same exact thing, but looks a little different. This is a function style cast, and this is probably more rare to see, but you put the parentheses around the object that you're converting instead of the type, and it looks more like a function call, like converting to a float. So this works fine for lots of different conversions, but it can also be a little dangerous. So there are some conversions that should not be done that this will allow, just because of how it works in the C language. In modern C++, what we prefer to do is to use a special cast called static cast. So static cast will do practically the same thing, but it's written differently. It looks very different. It's a lot more typing, and that's kind of a drawback. But it also does compile time testing or checks to make sure that this type is compatible with the type you're converting it to. So there's a lot of cases where a bug or an error can appear in your code, and if you were using the old style casts, it wouldn't catch it, and it would just crash your program when it runs. And static cast, on the other hand, will catch that. It won't catch everything. There are some special casts that we'll talk about in a later lesson that that are useful in addition to static cast. So one of the things that casts are really good for is disambiguating function calls. So let's say I have two very similar function call functions. Alright. So this one works on integers. And this one works on floats. Alright, but otherwise they're very similar. When I pass a value into one of these functions, it might not be clear exactly which function I want to call. So my function 5, which one is that going to call? Is it going to call the integer version? Is it going to call the float version? Technically, since 5 is an integer literal, it's going to call the integer version. But if I wanted to make it clear that I wanted the float version, I could static cast that. Now it's kind of a bad idea for constants, because I could just do a float literal here, but hopefully you get the idea. So if there's ever an issue and it's not clear which one you want, you can make it clear. But then there are cases like if I was passing in I, but I actually wanted to call the floating point version, then I'd want to use a cast in order to make that in order to do a conversion of that object and call the function that I intended to. And then the last thing is to force a type conversion. So there are some cases where you might be calculating values. I think we saw this in some of our code before. So let's say we have an array of grades. And you want to calculate the average. These grades are stored as integers, and if I did like an integer sum, this makes sense, and then I can loop through all of these things. Alright, let's add them all up together and store them in this sum. And then I can calculate an average, right? Sum divided by 4. However, this is not going to calculate the correct value. This is doing an integer division, because that's an integer and that's an integer. And it's worse when one of these is not a literal, when I have like some variable that's an integer. So it really looks like I'm doing the right thing, but this is still going to throw away the remainder and give me an integer that gets stored as my average. When what I'd really like to happen is floating point division. So I have to convert one of these to floating point before the division happens. I could do this with float right in there. Just a quick conversion will do the trick. Alright, so that's what type conversions and typecasting looks like in C++. And you'll see these a lot more, and they'll become way more useful when you're working with inheritance and polymorphism. See you later.